So hi guys, there's something that always niggles all of us, and for me I was reminded of one of these things when I was looking in a blog recently about this kit. And now this kit is a little power supply, 30 volt 3 amp power supply, and I was reading a blog about what people thought was right and wrong about it, what was good and bad, and one of the comments stuck out at me, and it's to do with these, the humble resistor. And what it said was, some of the resistors are running quite hot. So what you should do is put in some higher wattage resistors and then they'll run cooler. That isn't right. You know, any resistor that is emitting 1 watt of heat will continue to emit 1 watt of heat if you put the same value resistor in, because it's current squared times resistance. That's the amount of power. And it doesn't matter what wattage you put in. So I thought I would do a little experiment on the desk just to show that. Now there are some things that do matter. Physical size. If you put a larger physical resistor in, then that will convection will take the heat away more easily, for example. But anyway, let's run an experiment and just see what I'm talking about. So what I've done is I've set up 3 resistors in series. Now this ensures that the same current is passing through them all. And the amount of current that I'm going to pass through is 158 milliamps. And the reason for that is 0.158, so 158 milliamps. We square it, and then we multiply it by 10, which is the amount of ohms in the resistors I'm testing. We get 0.2496, so 0.25, so 1/4 of a watt. Now on here we've got a 10 ohm 1/4 watt carbon resistor, a 0.6 watt 10 ohm, 5 watt 10 ohm resistor. So all of these will have that same current flowing through them. So every single one of them, since they're 10 ohms, is going to be dissipating 1/4 of a watt of heat. This 1/4 watt one and the 0.6 watt are very, very similar size. I would say in fact the 1/4 watt is fractionally bigger physically, but there's not a lot in it. Obviously this one is huge in comparison. So we're expecting to see similar amounts of temperature reached for both of these two when we actually put some current through it. They're going to reach the same temperature. This one is going to be cooler. So that's wisdom according to me. Wisdom according to the blog that I read recently is that this one will run cooler than that one, because it's twice the wattage resistor. No, it doesn't work. Just doesn't work, does it? I just, yeah. So how will we know that? Well, on this stand above these is my thermal camera. So this is a clamp, and it's just mounting my thermal camera looking down directly at them. To provide the power, we've got this simple power supply just here, and you can see it's set for a very high voltage, high current, 35 volts, 10 amps. It won't actually draw 10 amps. We'll be controlling that with my DC programmable load. So here's the programmable load. And we can see we've got it set to 0.158, just like I worked out on my calculator. So when we turn this on, that is what it will draw. So I'm going to turn it on now, and it's drawing nothing because my power supply isn't on. And then I'll turn my power supply on, and we can see that it's now drawing round about what we expected. And yeah, these resistors down here will be warming up. As you can see, none of them are having any particular problems. But we'll switch to the thermal. Well, I'll need to kind of just rearrange these so the thermal camera can see them, and then we'll switch to the thermal camera and have a look. So on the picture you might see what looks like a little bit of misalignment, but that's because the thermal and the visual image are fractionally misaligned, and I might just have to kind of wiggle that around a little bit once I've got everything up and running. Here we go. So looking at this, I've got my soldering on in here to keep the hotspot away. We've got 38, 37 and 21 as our different temperature points. So really the difference between this guy here and this guy here, so the 1/4 watt and the 1/2 watt, which are the same physical size, is virtually nothing. Okay, and I am now going to turn up this current quite a lot, if I remember how. And we should see some temperatures starting to rise. Yep, there are our 3 resistors. Now these are all running well in excess of 150 C at the moment. I'm just kind of looking to see if any of them are discoloured. Now, fully enough, this guy just here is actually picking up a discoloration. This looks perfect. And I'm running 380, nearly 400 milliamps through these at the moment. So I'm just going to crank it up even further. And we can see that that one started smoking first, then that one. And in actual fact, that big one, of course, doesn't care one little bit. Interestingly, it's the 0.6 watts that's continuing to go. This one has already given up the ghost on this side. And they are actually conducting still. Well, and there we go. Flame from that type, not that type. So these two are different composition. This is carbon, this is metal film. So we can kind of see what happened differently about those. This is now disconnected. Actually, there's no current flowing through here. That bit of flame on there has disconnected the current, which in some ways makes it safer. However, the flame makes it less safe, so who knows. You can, of course, get these in a form which are flame resistant, so they're not going to do that. Anyway, okay, let's sum up and bring this to a conclusion then. So the first thing is, I'm not suggesting that just because a half watt and a quarter watt actually generate the same amount of heat, that you can just use one or the other and without thinking about it. Of course, you should obey the power ratings in order to operate the resistors safely. 2 resistors the same size but different wattage. What is going to be the difference is the tolerance that they have to that heat. The 0.6 watt will actually get hotter before it breaks down compared to the 0.25 watt. But they'll both get very, very hot, of course. Now, higher wattage resistors, I think where the problem comes in for people is that, generally speaking, they have a larger physical size. And it's that larger physical size that means that they appear to run cooler. They, of course, do still put the same amount of heat out into your case or your instrument or whatever it is that you are working on, but the surface temperature is lower. And that's because bigger resistors have larger surface areas, and same amount of energy over a larger surface area translates into a lower surface temperature. But it's only the surface temperature, not the amount of heat they put into your project. Now, traditionally, a 1 watt resistor would be a lot larger than a quarter watt resistor. Now that's not necessarily the same, and of course we've got surface mount, which can be very small. And I was just looking recently for some 2 watt resistors, and I found them in 0805 size, which is typical for about a 1/8 of a watt resistor. Now, I needed the heat to go away, so I chose a much bigger, I think it was a 1210 size resistor. Other things can affect it though. So coatings, for example, different types of coating on different types of resistor, they're there to protect the resistive elements, but they can actually transfer heat differently, so they can act more like an insulating cover, and therefore that resistor internally will get a lot hotter. So best solutions for avoiding hot resistors, well, the first thing is actually to redesign a little bit. So if you've got a Zener running through a resistor, think about getting a better Zener that has a lower current. That means you can use a higher resistor and you'll have less current and less power waste as well. And that's definitely something we should be thinking about in today's environmentally aware world. Another simple thing you can do is actually just stand them off from the board. So you can actually just form the legs so that they stand physically above the board, or you can just get some kind of like ceramic standoffs so that they don't touch the board, and air can get around them a lot better, and that helps them cool, particularly if you've got a fan moving air. Physically bigger resistors, of course. So you might have the white wattage resistor, but just get a physically bigger version of it and it will appear to be cooler. And if you're using surface mount, think about using larger lands or larger pads for the actual ends of your resistors, and actually even perhaps using vias to pass that temperature through to the other side of the board and get rid of it there as well. So I'm going to call it a day at that. Hopefully that was of interest to you. Of course, as usual, comments down below. Don't forget to subscribe, and I'll see you next time. Take care. Bye for now.